and you can watch a video, and so it will help you with your team, and you'll get to see other teams doing the same project.
Okay. Yeah.
Okay, introduce yourselves.
All right, so hi, I'm Alex Desso.
I'm Isaac Campbell.
I'm Lucas Rosenblum.
Thank you for doing this project. Nancy, you want to introduce yourself briefly to
Sure.
them?
My name is Nancy Hall. I am a project manager here at the NASA Glenn Research Center in Cleveland, Ohio. And I'm also the Glenn Regional Mentor for schools in my area. So I cover schools in Ohio, Michigan, Minnesota, Wisconsin, Missouri, and portions of New York. And then I also help Flo with some of her schools. So looking forward to seeing what you guys have designed.
Awesome. So I made it so you could share your screen if you want. You
Yep,
just have
we're gonna bring
Okay.
up their screen right now. All right, just confirm that you can see the slide deck.
Yes.
Yes.
Okay, we're gonna minimize this, guys, just to make it easier for you to see. All right, and then everything you
Yes.
advance, you do with a click.
This is title. You already know us, so
So basically, you already know the problem, but we just added it so we know you understand. Our goal is to eject trash in the form of in space, so astronauts can get rid of their waste technically. We want it to reduce mass, and therefore we have to use less fuel. So, like you said, it will cost a lot of money for weight and stuff. So we try to minimize that as much as possible, and we want to improve the quality of air and life in the spacecraft. So we want to have a clean environment in there and have only fresh stuff in there.
Awesome.
So when we started researching, we wanted to use flywheels, like when you eject a football in like a launcher. The launching mechanism, our first ideas was to use a bunch of springs to compress the soup can to launch it, but then we quickly changed that up into and combine all the springs into one bigger one.
this was. I also like to add that these were just a variety of things that we considered. We considered using the flywheels. We also considered using springs. This was in our research.
So as you can see on the left was our first invention on a launching mechanism, which we used a wheel to rotate a string to pull the springs back, and that would compress and launch the soup can out. And on the right was our first like what was it called? Hatch design. Sorry, it was our first hatch design, and we put an axle in there to basically hold everything and make sure it rotates around one. And when you rotate it, it closes one side and opens the other, so the soup can shoot out.
Yeah, not most visible in this picture, but on the other side of the tube, there was a separate wheel with a hole on the other side. So when you rotated it one way, it would open one side and close the other. So you could do that by rotating it.
So these are the criteria and constraints, and I know you're probably already informed about these, but they're basically just you must be able to eject the soup can, and you don't really want to have a lot of air loss in there, and the hatch, yeah,
can't lose that. Yeah. So we had our three ideas as we mentioned in our research. We considered the cost that it would cost to buy, how complex they would be, and likely to fail, which we would like to minimize as bringing spare parts is expensive, and how long it would take us to make sure that we didn't want to do anything that took too long to develop, otherwise we wouldn't be ready for our presentations, and reliability, as we didn't want to have things fail in space, as it is quite far from any convenient resupply. So after these, we decided on using springs to launch that after doing this research.
So this was our initial prototype.
We had a rack and pinion design with a slip gear to release the energy from the springs. The rack and pinion would pull back and compress the springs, and the slip gear would release it, shooting them out. The problem with this was that the motor was way too weak. The springs were definitely way too weak to shoot a soup can, and those cardboard plates kept breaking and bending.
And even after we reinforced these and added more springs, this general issues continued. But we fixed it.
This is our new prototype that we have made. It has a much more strong spring and definitely a higher gear ratio, a more powerful motor, and we move the spring to a different side of the mechanism to limit the bending in the metal from the pressure of the spring.
We also since we have been working primarily on the mechanism,
Mhm.
we don't have any kind of physical prototype for the hatch as of yet, but we have made a few CAD models just to demonstrate an idea. This one would have a drawer. This one would have a drawer that could be pulled out. The object would be put in, and then the launching mechanism would be contained within the drawer. It could be then closed. The hatches could be rotated and launched outwards. However, this one would have quite a large protrusion on the outside of the spacecraft, which could lead to issues while being launched. So this is a second design that instead has this mechanism hit it from the side, and it would slide open and closed and have a very small internal footprint.
Is that it on the slides,
That
guys?
is also,
Do you want to show them how the mechanism works?
yes.
Okay, so we're going to
Yeah.
transition back to the live camera. If there are any questions from the slides before we pull them off.
My only comment is I liked how you did your comparison with spring pistons and wheels to finalize it. It's always great seeing when students do that. Here at NASA, we do things similar, and we call them trade studies, where we look at different aspects of different designs before we make a final selection. So it was very nice to see how you guys had done that.
Thank you.
All right.
Yeah,
so-
let's see your wow.
Oh, wow.
It is an empty can, so it might go a bit farther than faster than the actual one. Yeah. As we have a 25-to-1 gear ratio, it can take a little while to get up to speed.
Whoa.
Nice. Okay. So one thing do you guys measure the distance when it travels?
No.
Not yet.
Okay. Yeah. So definitely as you do more testing, measuring with an empty can is good. To have someone videotape it so you can see it. I see you doing it on a desk. That's fine. I'd recommend doing the floor. That way you can see how much it goes. And with the measurements, something you can do that's real simple is just put a ruler or something with tick marks and then just have someone there so they can kind of mark it. That's why the video is real nice. If you have a video camera, you can see, or if you have different marks. But no, it's very nice.
Thank you.
It's a great design and it works real well. So do you have a way to control how much you pull the spring back?
The slip gear is what determines how much the spring is compressed.
Yeah.
So you don't have it. We can't just, if we wanted to only compress it half as much,
Right.
we wouldn't be able to do that, as it would require changing out the gear.
Uh-huh. Okay, because I was just thinking, it might go too far or
Yeah.
might go, but that all depends then on your slip gear, and you can change that out to
Yeah.
so that would be good. How about the direction that it's going at? Could you just put your device in a different direction and like put it if you wanted to go like 45 degrees out of there, you could just, is there any way to elevate it some, or it's just a horizontal plane there?
Don't don't have any means of altering the angle as of now.
Okay. Okay, that's good. But the design looks like it would work real well. How about the materials that you need to think about the materials that you would want NASA to use.
Yes. Yeah, we're not asking you to use those materials, but from reading the the objectives, you want to say if NASA was to design this, this is what we should use. So make sure to research that. And Flo, I do have one other comment. And I knew there was a reason I was asking to measure it. One of the things it says here is make sure it's ejected no faster than 1 meters per second. So
Yeah.
that's something you guys can calculate. You know how fast it's going, you know the distance, so you can calculate the speed. So make sure you're able to do that and see what that number turns out to be.
Right. And you can change the speed by changing that slip gear if it's too fast.
If we can.
Yeah,
So-
very good. Yeah, I think that's a good feature there.
Yeah.
But
No,
overall, very nice.
I really like it. You did a very, very original, and it works really slick, which is important. So, do you have any questions for us?
Okay.
What would the mass weight be if it was maxed out? Like, what is the max weight that we can use?
I don't think we have a max.
I don't
weight.
think we have a maximum, but ideally, what you want to do is you want to make it.
As light as possible.
Yeah. I mean, it talks about the mass if they were to use all the trash, but that's again where, since we don't know the mass, that's where, as you do your research, look at the different types of metals that you would use, types of springs, and use that as a guide to determine, oh, I have a choice of using like stainless steel versus iron. Well, or aluminum. Well, using that aluminum is lighter, but then how strong is it? So that's where you want to do some research. And that's one of the reasons you would state, I would use this material over another. It's lighter, it's less mass. But I
Right.
don't think you need a mass for the whole thing.
Right. And you can use your whatever you have available, but then
Yes.
do the research to say, well, but if NASA made it, it would only weigh this much. Right?
All right, thank you guys. So that was our bell.
Yeah.
Flo and Nancy. So we're gonna send these fellas off to their next period class. Thank you for the opportunity to present. And I believe our next slotted one was for 9:15, if I'm not mistaken. So
Yeah.
Yep.
So you did a great job. Keep up the good work. It is really a great demonstration and a great way to do it. So thank you. Go to your next class. Have a wonderful weekend.
Yes, nice work.
And thank you so
thanks,
much.
guys. Good job. Thanks. Put this off the side in your project box.
Okay. So Flo, you want me to just come back at, like, you can stop at 9:15, or are you gonna stay on?
Well, let's see.
It's only about half an hour.
Yeah. I'm gonna go eat breakfast.
Okay.
I'm gonna go track down some coffee. So I'll see you all in a
guys
couple
in
of
about
minutes.
half an hour. Okay.
Okay, thank you. Yeah, I'm gonna I'll just stop this one and then start a new one.
Sounds good.
Okay.
Okay.
Bye.
Thank you, Nancy. Thank you, Chris.